Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 3-3 lesson on adding and subtracting rational expressions. In this one, we are going to be adding and subtracting rational expressions, and as a real-life application, we'll see if we can put all that together to find a formula for profit. For the warm-up, here's a problem that you might be able to do based on your current knowledge of fractions. You may not be used to working with things with x's before, but let's just pause the video and give this a shot and see where it goes. All right, let's see what you came up with. So in general, when I'm adding fractions, I want to make sure that the denominator is the same. In this case, it is. So if that's the case, then we just move on to the next step, which is to add the numerators together. In this case, 7 plus 5, that's going to give us 12. And then we're going to keep the denominator the same. So we're not going to add these two x's. We're just going to have a single 2x down here. It's kind of, you can think of it almost as like combining like terms. If I had like 7 apples plus 5 apples, I would end up with 12 apples, not like 12 apples or something weird like that. Next thing to do is just make sure to reduce if it is possible. So looking back here, we see that 12 and 2 are both divisible by 2, so I can reduce those. That'll be a 6 over an invisible 1 down there. And then I can just write my final answer of 6 over x. So this is going to be our fully simplified fraction. Here's another example where we have the same denominator. Pause the video and give this one a shot. Just make sure that you're careful when you combine these, and also don't forget to reduce at the end. All right, let's see how that went for you. So one thing I know for sure is that since my denominator is an x squared minus 25 for both of these, I'm going to end up with an x squared minus 25 in the denominator of whatever this combines into. Next, I'm just going to write everything up here. So I've got 6x minus 11. And then I'm going to apply this negative to this whole numerator here. So make sure you distribute negatives when you are subtracting numerators. If there's more than one thing in the numerator, they both have to be negated. So this is going to be minus 9 minus 2x. Next, we can combine some like terms up here. We've got a 6x minus 2x, that's a 4x. And then negative 11 minus 9 is going to give us negative 20. So we have the same denominator and a 4x and a minus 20 going on. And then don't forget, at the end of these, after you've combined things, you always have to check to see if you can factor and reduce. So it looks like a 4x minus 20. I can factor out a 4 from there. That's going to leave me with an x minus 5 inside there. And for x squared minus 25, I can use my plus minus shortcut, a plus b, a minus b. So that's going to be x plus 5 and x minus 5. And looky there, I'm glad I factored because these x minus 5s, we know we can cancel those now, leaving us with just a 4 over x plus 5. And I don't need the parentheses down there anymore if that's the only thing down there. For this example, we've got a little bit of a game changer here. Looking down at my denominators, I notice those are different. So I can't just add these together the way they are. It would be essentially like 2 apples plus 7 oranges, which wouldn't give us anything intelligible. So if we have different denominators, we have to begin by finding a common denominator. So the best denominator to find is going to be the what we call the least common denominator, or the LCD. This is the smallest term that's divisible by each of those denominators. So pause the video for a second, see if you can figure out the LCD, the smallest thing that 3a and 12 are both divisible into. All right, do you think you have it? So what I like to do is a little trick here. I like to start with the numbers first, 3 and 12. And I ask myself, what's the smallest thing that those go into? I'm going to start with the larger of the two, 12. Is 12 divisible by itself? Of course it is. Is 12 also divisible by 3? It is in this case. That means that 12 then is the LCD between 12 and 3. Now, if 12 was not divisible by this other number, then I would start taking multiples of 12, like 24, 36, 48, until I found something that was divisible by all of my denominators. Next, I'm going to move on to the letters. Now, the only letter here is A. If I want something that's divisible by this A, I'm going to have an A in the thing I'm dividing into. So my LCD needs a 12 and an A. All right. Now that we've got that, our next step is going to get all these fractions to have this denominator of 12a. So in general, to do that, I'm going to multiply each fraction by what I call a fancy form of 1, or a FFU, in order to get the LCD. There's something over itself that I can multiply each of these fractions by that's going to give me 12a in the denominator. Pause the video and see if you can take this problem the rest of the way based off of that. All right, so let's check out what happened here. My first fraction, I've got a 3a in the denominator. Now, to get that to be a 12a, I'm going to have to multiply 3a by 4. But I can't just multiply the denominator by 4. I've also got to hit the numerator as well. So I'm going to multiply this first fraction by 4 over 4. Now, the reason I call this a FFU, a fancy form of 1, because what is 4 divided by 4? Oh, it's just 1. I'm allowed to multiply by 1. 1 does not change the value of the thing that I'm multiplying it by. That's what makes this legal. We're not changing the value of this fraction. We're just giving it a little makeover to make it more useful. We're going to do the same thing with 7 over 12 now. In order to make that 12 into a 12a, I'm going to have to multiply that fraction by a over a. All right, so let's see what I have when I simplify each of those products there. For my first fraction, 2 times 4 gives me 8. 3a times 4 gives me 12a, so I have 8 over 12a. Now again, this is equivalent to 2 over 3a if we were to reduce it, but we're kind of unreducing it to make it more usable later on. For this next one, I'm going to have a 7a over a 12a, and we're adding those fractions. At this point, now that I've got the same denominator, I can, again, just add my numerators and keep the denominator. So 8 plus 7a is just 8 plus 7a. I cannot combine those because they are not like terms. And then we have that 12a downstairs. Taking a quick look here, there's nothing I can really do to factor or reduce this, so this is as simplified as it's going to get. And that's the end of part 1 for this lesson. In part 2, we'll take a look at some problems where we need to factor before we can even find the LCD. But until then, see you later. On this next problem, we've got some different denominators, which makes this a lot more challenging than what we've already done. So here are some tips for finding the LCD when you're dealing with algebraic expressions. First good tip to do is, well, since the least common multiple has all the factors of each denominator, you need to actually factor the denominators to figure out what you're going to need to include in your LCD. So let's take a moment to do that. So we can factor pretty much everything in the denominators here. This first one we can take out a 5. That leaves us with an x plus 7. And for this other one we can take out a 2, which fortunately also leaves us with an x plus 7. So it helps that we have some of the same factors. Now the next thing I'm going to do, the LCD really has 2 parts to it. You have your normal number coefficient out in front, like these 2's and these 5's, but you also have those variable factors like the x plus 7's. So I always start with the coefficients. So find the LCD for the coefficients just like you normally would. So we have a 5 and a 2 to deal with. Well, 2 doesn't go into 5, so the next multiple of 5 is 10. 2 does go into 10, so then we have a 10 for that part of the LCD. Now we also have to take into account the variable factors. So we're going to multiply that number that we just got by all the unique factors that have variables in them. So we have an x plus 7. That's going to need to get included in our LCD. And you might be thinking, well, we have another x plus 7 over here. So how many x plus 7s do I include, 1 or 2? So what we're going to do is you're only going to duplicate factors if they appear more than once in a single denominator. But since there's at most one of these x plus 7s in each of these denominators, we only include one x plus 7 here. Another way you could think about it is the LCD has everything you need to completely cancel out each of the denominators if you wanted to. We're not doing that, but that's kind of a good test for if you've got everything you need in the LCD. It has the smallest amount that you need to cancel them out. All right, so we've got our LCD. Now what? Well, just like before, we're going to multiply each of these fractions by whatever it needs, whatever foo it needs to give it the LCD. This first fraction, what does this need to get 10 parentheses x plus 7? Well, we've already got the x plus 7, so really this 5 just needs to turn into a 10. To get that, we need to multiply by 2 over 2. How about this next fraction with the 10 and all that other stuff? Well, we've, again, already got the x plus 7 down here. This 2 needs to turn into a 10, so for that we need to multiply by 5 over 5. Let's see what that ends up coming out to. So for this first fraction, we've got a 6 over 10 parentheses x plus 7. And you should get 10 parentheses x plus 7 for both of these. That was kind of the whole point, was to get the same denominator. For this next one here, we've got minus, and then on top we've got a 50, and the LCD down on the bottom. Okay, we've got the same denominator. Let's go ahead and subtract those numerators now. 6 minus 50, that's going to be negative 44. And I'll put the negative out here, and we still have the LCD down there. Now, as always, check to see if we can reduce. Can't do anything with this x plus 7, but 44 and 10 can interact a little bit. Those are both divisible by 2, so we have a 22 upstairs, and downstairs that 10 is now going to be a 5. And just rewriting things neatly, we have negative 22 over 5 parentheses x plus 7. So for those of you who are wondering where you would possibly use addition or subtraction of rational functions in real life, here's one such possibility. Let's say for the first 5 years of its operation, the Feel Good Health Clinic's revenues can be modeled by the R function below. So we have R of x equals this weird rational function. And keep in mind, this doesn't model it for all of time. It just works within the first 5 years. And this is just a curve that happens to fit the random data that makes up the revenue. Okay, now the cost function is modeled by this C function below. So we have revenue and cost. We want to find a function for profit. Well, if you know the revenue and the cost, how do you find the profit? Economics lesson. We have to take the revenue and subtract the cost. And whatever's left over is the profit. So revenue minus cost, which in this case means we're going to have this R function minus this C function. So there we go, real life situation where we have to subtract rational expressions. How do we simplify this? Stay tuned. So here we go, trying to simplify this problem. You might be thinking kind of like this ambulance driver and want to hightail it out of here, but just relax, take a deep breath, factor, find your LCD, use the foo, combine things, and then reduce if you can. Pause the video and get as far as you can. All right, so again, to find the LCD, because these don't have the same denominator, we need to factor. The only thing we can factor, at least for the denominators, is this bottom right one here. So we've got factors of 18 that add up to negative 11. Well, there's 1 and 18, that doesn't work. 2 and 9 works if they're both negative. So we have x minus 2 and x minus 9. Now, you might be thinking, well, we can also actually factor this 9x plus 3, right? We could take out a 3, and then that's 3x plus 1. But although you're probably used to factoring numerators when you were multiplying rational expressions, it doesn't really make a whole lot of sense to do it when we're adding and subtracting them. Because the stuff up here is probably going to either get multiplied by some foo, or it's going to have to get combined with some stuff over here. In which case, you're going to have to multiply the factors back out anyway. So you're actually costing yourself some time if you bother factoring this stuff. The only time it would make sense to factor the numerator, maybe, is if you could cancel out one of these denominator factors. But we can't. So moving on. This x plus 3 over x minus 9, that's got an x minus 9, so that's going to be part of our LCD. We've also got this x minus 2 that's in the LCD, and an x minus 9. Now, this x minus 9 covers this x minus 9 over here. Again, we only write a factor more than once in the LCD if it appears more than once in one of the denominators. Since each of these appears at most once, we just write them once. So this first fraction, we're missing an x minus 2 to give it this LCD. So we're going to multiply by x minus 2 over itself. How about this other one over here? Well, that actually already has the LCD. It's perfect the way it is. So we're just going to leave it. We have our work cut out for us with this first one anyway. So multiplying those numerators together, we're going to have to FOIL this out now. We've got x times x, that's x squared. X times negative 2, that's negative 2x. Then we have a 3x and a minus 6. Downstairs, we have our LCD of x minus 2, x minus 9. Again, that was kind of the whole point. And this other fraction doesn't change at all, so that's kind of annoying to have to rewrite it, but at least we don't have to think about that. At this point, we are going to combine those numerators together since we have the same denominator. So let me just rewrite a big fraction with one denominator now. And upstairs, being careful here, we have an x squared. We have a negative 2x plus 3x. That's a positive x, but you're also subtracting this 9x over here. So that's negative 8x when all is said and done. And then for the constant, we have a negative 6 minus 3, so that's negative 9. As always, check to make sure you can reduce this or not. So we have factors of negative 9 if we're trying to factor this here. Factors of negative 9 that add up to negative 8. Well, 1 and 9 does that if we have a positive 1 and a negative 9. So I'm going to write x plus 1, x minus 9 up here. And I'm glad I did, because these x minus 9s can cancel now. So that leaves us with x plus 1 over x minus 2. And I think you'll agree this is a much nicer function for the profit of that hospital than this craziness that we started here. So, we made it. Until next time, Mr. Sutton signing off.